Welcome to another electronic troubleshooting video at Mr. Carlson's lab. Today we're going to be finding an issue in this radio receiver. In order for this radio receiver to receive CW or Morse code, or if you like, if you're very careful, you can listen to sideband with this as well, we need to have a working beat frequency oscillator. And that's the problem in this radio receiver. There is no BFO working. So what we're going to do is we're going to troubleshoot that oscillator, find out why it's not working, make it work, then test it out. So in a previous video, I displayed this wasn't working. We'll take a look at that right now.
For your teammate, carefully searching the market, dozens of major carriers to find you the best fit. And that's it. No more stress.
Nothing.
No more confusion. The first smart team has spent the last 30.
So no BFO either. So we'll have to troubleshoot the beat frequency oscillator. So there's an example of what really isn't happening. So in order to get the beat frequency oscillator working, we need to test a bunch of stuff in this area and find out exactly what's going on. So let's get started. In this RCA CR88 radio receiver, very close to an RCA AR88 radio receiver in design, this here is the BFO coil right here. And this is the BFO triode or oscillator tube right here, which is a 6J5. So what I'll do is I'll zoom into this. Now you're probably saying, wow, there really isn't a whole lot of parts and pieces here. They're just, tube socket lead out pins tying over to the coil here. Well, RCA is being a little bit tricky, and I'll show you exactly what they're doing here on the schematic in just a moment. And I'll also explain a coding system that they're using that will ease the troubleshooting process here a lot. Other radio manufacturers have used this type of thing as well, so it's beneficial to know this. This here is a Mica capacitor on the outside portion here, just tied from one pin to the chassis. And we have another capacitor here tied on the outside, and the rest basically just runs right up to the tube. We have one unused pin here on the bottom side of this coil. They've loosely coupled the oscillator circuit into the third IF transformer through a light value capacitor, about 2 picofarad or so, and I'll explain what they've done there as well. So I'll get the schematic into focus and we'll compare the schematic to what we see, and I'll show you that coding system. This is the schematic diagram for this radio receiver. You're probably thinking to yourself, wow, that's a pretty busy looking piece of paper for that radio. And you're right, it is. There's a lot of stuff going on in here. And today we're going to be taking a look at the BFO section. So this is the portion that we're going to troubleshoot and we're going to repair, make this work again. This little area here. You can see the lead off wire here running up to the third IF and coupled into the third IF through that very light value capacitor, about 2 picofarad right there. So in order to see this a little easier, what I've done is I've zoomed into it, printed it off here. Now, if you're new to circuitry like this, there's a lot of things that would confuse, and I'm going to clarify all this stuff today. I'm going to cram your brains full of knowledge about these schematics and what they used to do way back when. If you're interested in servicing radio receivers like this, you might want to write some of this stuff down or take some notes, because it's very beneficial stuff to know. So the very first thing we're going to talk about here is the resistors. You'll see it says 120M and 47M. Well, if you're used to servicing modern stuff, you would think that's 120 meg and 47 meg. Well, no, it's not. The old coding system, instead of having a K, they put M there instead. So that's 120 K ohms, that's 47 K ohms. Again here, down here, right? You see 120 M, that's 120 K ohms. If it was denoted as meg, you can see 1 meg here. If the resistor is in the meg ohms, they'll write actual MEG. So that's quite confusing on these old schematics, and a lot of people get led astray by this. I've seen many people look for 120 meg ohm resistors and 47 meg ohm resistors, and all the resistors up that would be high in value like that, and they're like, I'm having such a hard time finding these really high values. Well, if you put those values in here, the circuit would not work at all, right? That resistance value is so high, there'd be no plate voltage on here to drag it right down, right? So that's one thing. Another thing is, if you're new to circuitry like this, and you're looking at this and you're tracing wiring out in here because the BFO isn't working, you'd think RCA made a mistake. Well, the leadoff wires from the 6J5 tie to 2 unused portions of the tube socket. Look, there's nothing in the tube attaching to these. In fact, they're so unused that the tube manufacturers didn't even populate the pins on the bottom of the tube socket. Do you see that? right? So that's all missing. So you're thinking to yourself, well, they're attaching wires to 2 unused pins. There must be a mistake. Well, no, there isn't. The BFO in this circuit, in this actual radio receiver, is pretty powerful. It makes quite a bit of a signal, and they just want to lightly couple this into the 3rd IF stage. In fact, they're still attenuating that signal with that 2 picofarad capacitor up there. Now, what they're doing is they're using the lugs in the ceramic tube socket to capacitively couple to pins around in order to give you just a little bit of coupling to bring that up there. So this is correct. To further confuse things, in the AR88, they don't couple to 2 pins. They only couple to 1. To further confuse things even more, in this CR88, they've only coupled to 1 as well. They haven't coupled to 2. So if there isn't enough coupling in this, if I wanted a little bit more BFO coupling, I could add a jumper on the socket and get a bit more coupling. All right. Or I could even go up there and change that 2 picofarad capacitor to something else. Which brings me to, this is the Grand Receiver Restoration Series here, and I'm going to be sharing tons and tons of receiver knowledge with you. Again, if you haven't subscribed, it'd be a good reason to do that now so you don't forget, and tap the bell symbol so that way you get notified as soon as I post new episodes in this series. But anyways, I'm going to be sharing tons of receiver knowledge with you. So once all of these radio receivers are done, the SP600 and the Collins radios and the Hammerlands and all that kind of stuff, and you know, the BC348 and all that stuff, once that's all done and we've compared them all, I'm going to go into these receivers and I'm going to start modifying them, and I'm going to make them better. I'm going to show you some very neat modifications that you can do to these things. In this case, to stabilize this oscillator circuit, to make this way more stable, so listening to single sideband or listening to CW or whatever will be much, much nicer. All sorts of little things I'm going to share with you here. So again, I'm going to cram your brains full of knowledge here. And again, that's what this is all about. It's just about passing this knowledge on, right? So lots of neat stuff coming. At any rate, so back to this. So when we looked at the bottom portion of the chassis, we only saw really 2 parts there. We saw the 4700 picofarad capacitor and that 0.1 microfarad capacitor, right? So I'll zoom in on that again here to show you that. We didn't really see many parts here. We see this and we see this. So that's that domino style Mica capacitor right here. I'll go over quickly how to read these again. I've had lots of requests for that and some other requests as well. And I've also had the question, are these actually paper or not? And I've had many people say that, oh, they're paper, they're paper. Well, I'm going to test these and I'll show you what's going on. I'll actually break one of them open and show you what's inside in this video as well. So lots of information here. So anyways, these are the only 2 parts that we really see aside from that leadoff wire that runs in here and up to that 2 picofarad capacitor, right? Well, looking at the schematic, where are all the rest of the parts? Well, RCA is being tricky. What they've done is they've put most of these parts inside the BFO can. So we actually have to take the entire can apart to replace any parts. Now, we don't want to have to desolder all the lugs and take the can apart and do all that if the parts inside are okay and say the problem's external somewhere, right? So how do we do that if they're hiding in the can? Well, RCA has a coding system on the bottom portion of their cans. You can see there's an A here, right? We can see a D, a C, we can see a B here, see the letter F. We see all of that stuff written here, right? So how do we use that to say test the components? Well, it's very easy. Let's take a look at the bottom portion here again. Pardon all the camera movement here. So we look at the bottom portion of the beat frequency oscillator. You can see A here, and then you can see E and F. So the way it works is it goes A, B, C, D, E, and F. So it goes around in a horseshoe shape like this. All right. So you can see the A is pretty easy to see. So if you get a flashlight, you can see all of the letters. I think you see the B right there, right? And all that all the way around, right? Well, since vacuum tube circuits are a relatively high impedance circuit, looking at this again, you can see that we have our 120 k ohm resistor here. We have our 47 k ohm resistor here. How would we test these? Well, we can test this resistor on the outside from this point to this point. So if we put one of the probe leads from our DMM on the letter F and one of the probe leads on the letter D, we'll test this resistor. You might be thinking to yourself, well, isn't the rest of the circuit going to confuse this? Well, no. The vacuum tube looks like an open circuit. All right, the plate circuit inside here is, I guess you could say, like a can inside there, and then we have a wire wound grid in the middle, and then we have a cathode right in the center of all of it, and then the filament goes up inside the cathode. Well, all we're seeing in this circuit is capacitance. When the vacuum tube is off and everything is there, this just looks like a complete open circuit. Well, if you look here, we're just capacitively coupled into different portions of the circuit, right? And this is leading off to the B+ section. So this is all just, capacitance. And since the capacitance is so light, the inter-electrode capacitance inside this tube is going to be in the picofarad region. It's not going to confuse our meter at all. So if one of these caps was shorted or something like that, and we were trying to test the circuitry, or something was shorted, in the rest of the circuitry here, we might have some form of an issue. But it's very rare, again, that these capacitors are going to short. This one's been replaced. There's a new poly here. The chances that this one is shorted and the rest of these are shorted is, pretty slim. Again, it is possible. We found some dead ones in the last episode, right? Noisy and leaky capacitors. But it's, pretty slim that they're going to come to a dead short. So we can test this resistor here by going from D to F. And we can test this resistor here from going from D to C. And all that kind of stuff, right? So we can test this one here from A to B. Right? We can test this 120k ohm resistor here from A to B. And that's what we're going to do, so we don't have to pull this whole thing apart and find out that, hey, everything is fine inside that can and the problem's external, right? Because that would be a real big pain to do all of that. So what I'm going to do is I'm going to get a meter hooked up, a DMM, and we'll just start probing this. Oh, another thing, you might be wondering, what are these capacitors doing on the outside of the can? These are just blocking capacitors. So what they're doing is they're trying to keep the signal off of the B+ line. They don't want any of the beat frequency oscillation getting out of that can. Again, they're trying to keep as much stage isolation happening in this radio receiver as possible. And they're also trying to keep the circuitry as quiet as possible. All right, so that's why they have these two capacitors right here. So we have a 120k ohm running to the plate here, right, which is our basically load here. And then we have this other, you could call it a dropping resistor, and it's actually acting as some isolation as well here, right? It's a kind of a lighter value resistor here, dropping things again. And we have the capacitors across that. So we're just keeping things nice and quiet, and of course reducing B+ and keeping the strength of the oscillator down. So that's all that this is for on the outside of that can. They're just blocking caps. You can look at them like that. It's nice that at least they put those on the outside, right? All right, I'll get a meter here, and let's start testing some of these values. All right, let's test some resistors inside the BFO can here. So R29 is 47k ohms, and that goes from D to C. So you go A, B, C, and D. So let's go across here. So it should be close to 47k. 48.4k, absolutely fine. No problems there. So 120k ohms from F to D. So this is D, E, and F. So this would be F and D right here. 121k ohms, not a problem. No problems there. So let's test this 120k ohm resistor, and this goes from A to B. This is A and B. 120k ohms. So no problems with those resistors. So the resistors are all fine here, and as you heard, there was no BFO action. So the next thing to do is to look at the circuit itself and see if it's actually oscillating at all. So I'll get a scope set up and we'll take a look at that. All right, the receiver's been warming up for a while, and it is in CW mode right now. So I'll tie the scope into, say, pin 4. I believe that's the unused pin on that socket there. So let's do that. Turn on the scope. And all right, so what I'll do is I'll attach the probe common just to the chassis here. And see if I can clip this in. All right. So nothing happening here. It's on auto, so it's going to search for a signal. So there's nothing there. So what I'm going to do is turn the BFO control over here. Let's see which one is. I think that's the BFO there. Turn that. Oh, we have something going on here. Look at this. So it found it. It's 457. So what I'll do is I'll take that off of auto, put that on manual. So it'll just hold this here so it won't, the horizontal time base won't go moving around. So it's stopping. It's actually, when I turn the control, it's stopping here. So it almost looks like it might be, let's see what's going on here, 460. That's quite a ways. 462, 459, 457, 455, 4, and then it just stops. Yeah, it's almost like there's something, maybe the control itself isn't making connection. So that's just a variable capacitor. See, it's completely stopped right now. But when we listened before, there was no BFO action at all, no matter how I turned that. So let's turn the volume up. And it sounds like there's no, oh. You can hear that in the volume control, right? So here, let's get the speaker a little bit closer to me here. And I'll turn this. It's actually quite a huge range that's not actually working in there, and then it's starting to work. So it's actually doing a little more than it was. It sounds like it. So I'm just wiggling the control right now. So it's almost like it's not making any connection, or in that one spot, at any rate when I move it. So I'll just turn this around a little bit, carefully. All right, so this is the BFO here. So it might just be a bad connection in the capacitor, or maybe even a bad solder joint on the top portion of the chassis here. So I'll get things moved around. Let's take a look at the top portion and see if we can see anything wrong with that beat frequency oscillator capacitor, variable capacitor. Well, it looks as if the problem's pretty obvious here. So if we take a look down at that capacitor, down in there, you can see right there is a shorted plate, right about there. See that? How that's rubbing? So they're not supposed to touch at all. So somebody's bent that plate. So it's much like the main tuning capacitor. This thing is full of bent capacitor plates. It's really kind of strange. So if I go down here, stick my finger in there, I think it's that one there, bend it back just a little bit. It's almost free there. That's looking much better, isn't it? Is there anything touching on the other side? That looks pretty straight. Yeah, I think that's about straight there. Lots of bent capacitor plates in this. It's very odd. Very rarely do I come across shorted cap plates in, BFO circuits or any radio in general. And this one has had two in the main tuning cap and now in the BFO capacitor down here. Kind of interesting. So what I'll do maybe as I'm here, just to make things even better, if I have any, I don't think I do down here. What I'm going to do is I'm going to grab some, just some contact cleaner and spray some in there just to make sure the contacts are very good. This is, you can see how this is rubbing. I'll grab a pointer here. You see how this the rotor rubs up against this little block here to make connection to ground, right? In some cases it's chassis ground, in some cases it's isolated, but it makes connection with this block here. And if that's a bad connection between the rotor and this little kind of a spacer washer-like thing right here, we'll get an intermittent signal in the BFO. So what I'll do is I will spray that down as well. It looks like the spacing is pretty good. I'm just going to move the camera a little bit here so you can see that there's going to be a lot of movement because this is really zoomed in, so pardon the movement. So just move this back just a bit. Hopefully you can see that down in there, right about there. Oh, is it getting out of focus? Right about there. Yeah, so there is quite a bit of space in there. All right, I'll put this back up over here for a moment, just like so. Stay, don't fall. And I will go grab some contact cleaner and we'll try out the BFO again. Sure, it would be nice if it was that easy to fix this BFO. All right, this is almost empty. Hopefully there's enough in here to do it. I think there will be. Already feeling so much better as well. All right, what I'll do is I'll hook the scope back up and we'll take a listen to it and see if the BFO stays working. All right, the radio's on. This is attached back into circuit here, so I'll rotate the BFO. No problems, it's staying running. So it goes from about 462, almost 463 kilohertz to about 451, something like that. Not bad for a BFO that hasn't even been tuned. So the center should be about 455, right? Not bad. So that's it. It was just shorted plates in that capacitor, which is kind of nice. We didn't have to remove the entire can and take that all apart and find some component inside there, so that can stay all together. It seems to be working very good at this point. Let's see if this old RCA will actually receive any sideband. So there's not going to be too much CW around, but we can use the BFO to receive sideband. We just have to ride the RF gain control a bit. So I'll turn the volume up and I'll move around in amongst an amateur radio band, ham radio band. Okay, there's some sideband right there. So that's what sideband sounds like with no BFO. It almost sounds scrambled. So that's what it sounds like with no BFO. So I'll turn the BFO on, and I'll turn the RF gain down, and I'll tune in. So you can hear it there, hopefully. So there you go. So you can listen to sideband with that. And that's just using a standard beat frequency oscillator. So I have plans to, after the Grand Receiver Restoration series is done, and we've compared them all, I may even add a product detector to this, and I'll take you along through that entire journey as well, and that'll make listening to single sideband much, much easier on any older radio. In the previous video in this episode, we did some troubleshooting and found some noisy components. So these are the 3 noisy capacitors that were replaced in the audio section. And I've had many questions asking me, Paul, are these really mica capacitors, or are they possibly paper and foil and they're, squished in these molded capacitors? Well, the first thing that tells us that they are not paper and foil is this first dot here. That's a mil-spec component. The black dot is mil-spec. So they're not going to be putting paper and foil in any type of capacitor that is going to be mil-spec, especially for a receiver like this. So in order to, get rid of all doubt, I cracked one of them open. And on the bottom portion here, if I peel one of these corners back, you can see that that's definitely mica. So there's little stacked mica wafers or layers inside here. No paper and foil in these capacitors at all. Again, that's to be expected. So if the first dot was white, then it might be a paper and foil style capacitor. But since these dots are black, and of course, and they're put in a receiver of this type of quality, the CR88 and the AR88 type series of our radio receivers, there's no way that they're going to be, using this type of a paper and foil, construction in a receiver like that, especially for the duty and, the dependability that was required in a radio receiver like this. Now, I've had the question also, Paul, can you test these with your tester and just show us that these things are actually leaky? No problems, I will do that as well. That was another bunch of questions in the previous video's comment section here, so I'll just move these out of the way and turn this on real quickly and just show you that they are faulty. Okay, so we'll turn this on, just leave that on discharge for a moment, and I'll connect one of them up. Obviously this isn't the one that's broken, right? We'll turn this on, turn off some lights here so you can see, and as you can see it's red and it's still very bad. Very bad capacitor. All right, so we'll get rid of this one. All right, and we'll test the next one. And pretty much the same area. Very bad, not even getting into the second scale where it's yellow. So very, very bad capacitors. Alrighty, grab some other capacitors. This has been on here for now about 5 minutes. Hasn't even moved, right? So I'll just remove this. It's like so. And I'll just leave it on test. It might detect my hands here, so don't worry about that if it sees that. There we go. Okay, so there we go. So there's a new mica capacitor right there. Okay, and this is on the forecast test. All right, so it's very, very sensitive. All right, new mica, no problems, right? So we'll disconnect this, and let's try this one. This one is an older style mica like this one here. All right, mil-spec again. This is 2000. All right, 2000 picofarad. So 2, 0, and then 0, 0. Is that what it is? Yeah, 2000. All right. So let's put this on here. Look how quickly that one goes down. Right? So very good capacitor. Here's another one. So this one's a little closer. So this is 3900, a little closer to 4700. I'll just put this on here. There we go. Now keep in mind that this is in the forecast test, so this is extremely sensitive. So, of course, this value here, this capacitor here, moved a little slower, but it's even higher value than this. This one here is equivalent to these ones over here, 4700. So no problems with these, right? So, as you can see, that's discharged, and we'll do one more time. This is a, again, a capacitor here that's another mica. These are all micas. So I'll just discharge that there. And again, we'll go back to one of the old ones, right? One of the noisy ones here. Again, this is very uncommon for micas, right? So put this here and turn it on. That's as far as it goes. So very, very leaky. These are very, very noisy too, as you heard in the previous video. So this has most likely happened because they're by those resistors that are very, very hot. And of course, they've been thermally cycling, and it probably caused some issues within these capacitors. That's about it. So normally these capacitors are very, very dependable. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at modern electronics and antique electronics alike. So there'll be a lot of repairs, restorations, circuitry design, troubleshooting, all of that great stuff on this channel. So if you're all about electronics, like I'm all about electronics, this is the place you're going to want to be. Definitely subscribe and tap the bell symbol so that you're notified as soon as I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, many of which you've seen on this channel, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.